Just a little reminder, I think all of you are doing an amazing job. So, to continue what we've been working on, today we will investigate molarity so that we can understand the relationship between moles divided by volume. To review, molarity is another word for concentration. And in chemistry, we can calculate molarity. Molarity is equal to moles divided by liters. Sometimes we are not always given directly the moles or liters, and we have to make adjustments and calculate and convert. So, just before we look at the two problems we have here, let's look at some of our conversions. The first one we need to look at is converting grams to moles. Moles is equal to the number of grams divided by molar mass. The second conversion we need to consider is the number of milliliters to liters. Remember, there are 1,000 milliliters equal to 1 liter. All right, so let's take a look at our first problem. Seawater contains roughly 28 grams of sodium chloride. And here's a key word here that we can't ignore. It says per liter. Anytime it says per liter, we're going to assume that that is equal to 1 liter, right? Because that's per liter equals 1 liter. We're going to assume we're 1 liter here. And it says, what is the molarity of sodium chloride in seawater? All right, so again, I just want to point out, this is the ultimate formula we're trying to fill in numbers for. It's asking us what is the molarity, aka concentration. So we need to solve for M here. We know that it says per liter. So per liter tells me that that's for every 1 liter. However, one of our problems here is that it's 28 grams, and we can't use grams. There's no grams here. It's moles. So we first have to convert our grams to moles. All right, so let's take a look at this. Our formula is sodium chloride. If we look, we have to find molar mass. Molar mass of sodium chloride in order to be able to convert grams to moles, we have to divide by molar mass. And here we see we're dealing with sodium chloride. Sodium is 22.99. All right. So let's do our first conversion. 22.99. And our formula is NaCl, so we only have 1 sodium. The second element we need to find the mass for is chlorine. Chlorine's mass is 35.45. All right, so this mass was for sodium. We have 35.45, and we have only one chlorine, so we don't need to multiply it by anything. We need to add this together. I'm not going to pull out the calculator. Hopefully I can do this in my head. 9 plus 5 would equal 14. 9 plus 5 would equal 14. Carry over the 1. 5 plus 2, 7 plus 1, 8. And then 3 plus 2 is 5. So 58.44 grams per mole is the molar mass of sodium chloride. Okay, so we need to convert 28 grams to moles in order to be able to plug it into this formula. So we're going to start off with our given 28 grams, 28 G's of sodium chloride NaCl. And we're going to divide it by the molar mass, 58.44 grams for every 1 mole. All right, let's look at what our answer was. Here we go, big screen, pop. Looks like our answer, 28 divided by 58.44, should be rounded to the nearest hundredth. That means 2 places after the decimal, 0.48. So we have 0.48 moles. All right, let's backtrack. We're trying to solve for the concentration of basically seawater. We already know that 28.0 grams of sodium chloride are for every liter of seawater. So we just converted the number of grams to moles, dividing by the molar mass, which gave us 0.48 moles. And like I said, the fact that it said per liter tells us for every 1 liter. So even though it doesn't give us a very specific volume, it tells us the volume right here where it says per liter. So we need to now solve our molarity problem. Molarity is equal to the moles we just calculated, 0.48, divided by, our problem said per liter, which tells us only 1 liter. So 0.48 divided by 1 would equal 0.48 capital M of seawater. All right, let's take a look at our second problem. Can't seem to get rid of this one. That's not good. Give me a second. All right, our next problem says, what is the molarity? Remember, molarity is another word for concentration. So I could also say, What is the concentration? What is the molarity? I'm saying the same exact thing. Okay, so what is the molarity of 5.30 grams of, of sodium carbonate dissolved in 400 milliliters of solution? I need to circle that. All right, so we're being given grams and milliliters. I want to point out, remember, concentration or molarity is moles divided by liters. We don't have moles, we have grams. And we don't have liters, we have milliliters. So we have to do two separate conversions, and I gave those to you up here. Let's start with converting our grams to moles. Okay, so we have 5.30 grams of sodium Na2 carbonate, CO3. And we need to convert this to moles. All right, now this is going to be a little bit of work because so far we haven't had our conversions of grams to moles in these particular problems have been very simple. And this is not going to be so simple. We have 2 sodium, we have 1 carbon, we have 3 oxygen. So let's go ahead and figure that out. Let me add our periodic table real quick. Perfect. Here it is, real big. Okay, let's start with our sodium. Right here we see sodium is 22.99. All right, so let's start. We're going to start way down here. 22.99. All right, now I want to point out I don't just have one. Okay, one sodium is 22.99, but I don't have one. I have 2. So I need to multiply by 2. Then we have carbon. Let's take a look at this. Carbon is 12.01 if we're rounding to the nearest hundredth. All right, so 12.01. All right, let me go back. This is representing sodium. Our next one is representing carbon. Carbon is 12.01, and we only have 1 carbon. So I don't need to multiply it by 1, but if you need to see that visual, we'll say times 1. Okay. Next thing we need to look at is oxygen. Hopefully by now you know what oxygen's mass is. 15.999, which we round to, say it all together, 16. That's right, 16. And we don't just have 1 oxygen, we have 3. We have 3 oxygen. So we need to multiply that by 3. That's for oxygen. All right. And we're going to add this all together. All right. Remember order of operations. When using a scientific calculator, your calculator doesn't know what to do. You need to multiply everything out first, Then add all your answers together. And as you can see here, our answer is 128.98. So when we write that down, 128.98 grams per mole. This is our molar mass. Let me get rid of this over here. Okay. So now we know our molar mass. We also know that we're starting off with 5.30 grams of sodium carbonate. In order to make this work, we need to divide the grams that we are given by the molar mass. So 128.98 Gs, because that is the molar mass of Na2CO3, for every 1 mole of Na2CO3. We need to calculate that. Remember, whatever is on the bottom, we divide into the top. So the way you would do it is in your calculator is you would put 5.3 divided by 128.98. When I take that problem, 5.30 divided by 128.98, I end up my answer being 0.04109 da 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 da. We just need to round to the nearest hundredth. Okay, so there's a 1, this is 0, this is not going to change. Only the hundredth place would change if this was over 5. So our answer for number of moles is 0.04 moles of Na2CO3. All right, now we have our number of moles, and we also have our liters, because our problem is moles divided by liters. Our problem said, oh wait, no, we don't have our liters. We have 400 milliliters. We can't use this. It's milliliters. We need liters. So let's do that extra conversion. All right, so we're going to do 400 milliliters, and our conversion factor here is 1,000 milliliters would be equal to 1 liter. So if I have milliliters right here, I need milliliters down here. And if I go back and I'm looking at this, I'm looking at this, then I have 1,000 connected with milliliters, which means that's what's going to go down here. So 1,000 milliliters is equal to, right here, 1 liter. We know how to solve these. Whatever's on the bottom needs to be divided into the top. All right, I'm going to show you a trick here. I'm going to pull this to the side. I don't really have a whole lot of room here. We'll try to make the best of this. All right, let me use another color at least. Okay. If I have 400 milliliters, where am I going to write this? Oh gosh, we don't have a whole lot of room. Sorry. Okay, 400 milliliters. And I need that converted to liters. by dividing by 1,000. All we need to do, keep this simple. I'm always trying to keep this simple. All we need to do is move the decimal point over 3 spots. Okay, so look. Milliliters, it has 3 zeros there after the 1. So we need to move the decimal over 3 times to the left. So we're going to assume our decimal is after the 400. So 1, 2, 3. Which means our conversion for milliliters to liters, 400 milliliters to liters would equal 0.4. This is our volume. 0.4 liters. All right, so recap. We converted our 5.30 grams of sodium carbonate to be 0.04 moles of sodium carbonate. Then we converted our 400 milliliters to being 0.4 liters by moving the decimal over 1, 2, 3. So 0.4 liters. Now we're solving for concentration, and our problem is moles divided by liters. So we have our moles. Our moles, 0.04. 0.04 moles divided by our liters, 0.4. 0.4 liters. When I put that in the calculator, this is what we end up with. Let me show you. It's going to end up all big. We'll reduce it. So 0.04 divided by 0.4 is equal to 0.09999. We're ultimately going to end up reducing that or simplifying that to 0.1. 0.1. Capital M. We're solving for molarity. Our unit is capital M. And that's our problem. I know this seems like a lot of work, but I would never ask you to do something I didn't think you were not capable of doing. So please hang in there. Take your notes. Those are going to help you anytime we do any kind of assignment. I don't have an assignment for you today. I need you to take notes on these 2 problems because you're probably going to see them very soon. If you have any questions, please email me. We discussed just doing basic conversions and solving for molarity. And I'm going to be having office hours soon, so please take some time, again, to take some notes, go over this. I'm trying to keep it very short for you because I'm thinking about you guys and your well-being. And so tomorrow we will have more practice. Hope you guys take care. God bless.